Bismillahirrahmanirrahim. Assalamu alaikum dear students. I welcome you to the next section of the Linux lecture series. Today we are going to talk about signals. This is one of the means of inter-process communication used in UNIX. Basically, what is a signal? A signal is normally used by operating system to notify our running process that some event has occurred, without the process needing to poll for that event. Let me repeat again. Signals are used by operating system to notify our running process that an event has occurred, without the process needing to poll for that event. You can say that a signal is a software interrupt that is delivered to a process by an operating system because a process did something. A process did something which is not supposed to do. For example, it has accessed an illegal memory. Normally, once you do dynamic memory allocation in a process and you do pointer arithmetic, and once you try to read or write an address of the memory which you are not supposed to access, you get segmentation violation. That is basically a signal segv, signal number 11. This is a signal which is given to a process once it tries to access an illegal memory. And when a process tries to perform a division by 0, it gets a signal that is known as segfpe, floating point error. When a process tries to access some or execute some illegal instruction, it gets a signal which is known as segl, whose number is 4. Similarly, if a process tries to write on a pipe whose other end is closed by the reader, it gets a signal which is segpipe, whose number is 13, and so on. So signals are given to processes when they perform something which they are not supposed to do. So operating system gives them the signals and normally terminates them. At times, one process wants to tell another process something. One process wants to tell another process something. For example, a child process which has terminated, it wants to tell the parent that I have terminated. So when a child process terminates or stops execution, the operating system kernel sends a signal to the parent, that is segchild. At times, the user tries to send a signal to a process using the keyboard combination. User sends signal to foreground processes. By using the key combinations like Ctrl plus C. When a user presses Ctrl plus C, it basically sends SIGINT signal to the foreground process. Once a user presses Ctrl plus backslash, it sends a signal SIGQUIT to the foreground process. Similarly, when a user presses Ctrl plus Z, it sends a signal SIGTS TP to the foreground process. So there are a lot of signals. So if you want to see what all signals are supported on your system, you can give the command kill -L and press enter. Once you press enter, you will get a list of about 32 or 30 standard signals and 30 or 32 real-time signals on your machine. Let's do it over here. So here is our terminal. I'm in my present working directory. Let me give kill -L command and let me shrink the size a bit. Okay. If this is readable to you, you can see there are about 64 signals, out of which about 30 are or 32 are the standard and the rest are the real-time signals. The standard signals starts with SIG and the real-time signal starts with SIG RT. Every signal has an associated constant or name and a number with it. For example, SIG seg-v, which I just talked about, the signal which is given to a process when it tries to access any legal memory. SIG FPE, this is a signal which is sent to a process once it tries to do SIG pipe. SIG pipe is the signal which is sent to a process once it tries to write on a pipe which is closed at the other end by the reader process. SIG FPE is the signal which is sent to a process which performs a floating point error, for example division by 0. So there are a lot of processes and there are a lot of signals, and each signal is sent by the operating system to a process on a different occasion. So normally whenever a process receives a signal, it is interrupted from whatever it is doing and forced to execute a piece of code called the signal handler. And when the signal handler returns, the process continues its execution as if this interruption has never occurred. Let me go into the details by going to chapter 7 of the main pages, signal. I will strongly recommend that you should read this page, which tells you a lot about the overview of signals. Let me zoom it a bit. So first of all, the signal disposition, gentlemen. Signal disposition means what will happen when a process will receive a signal. Each signal has a disposition which determines how a process behaves when it is delivered a signal. So, okay. So the default dispositions can be term. The default action is to terminate the process. IGN means ignore. Default action is to ignore the signal. Core. Core means terminate the process and generate a core dump file. Stop means stop the execution of the process or suspend the process. Continue means continue the process. Okay, so there are a lot of information which you can read. Okay, these are the signals again defined by POSIX, SIG hub, SIG int, SIG quit, SIG ill, SIG abort, and their default actions which they take, and a bit of comment that tells you what happens when the signal is given to a process. For example, SIG pipe, as I have said, its signal number is 13, the default action is terminate, and it happens when you try to write to a pipe with no reader. Reader is here. Okay, SIG FPE value is 8, signal number is 8, the default action is core. The difference between term and core is, in case the action is term, the process is terminated, and if the action is core, the process is terminated as well as a core dump file is also generated. So you can go through this list, it's informative. Similarly, gentlemen, there is one more important point I want to mention is that there are main two types of signals, the catchable and the non-catchable. Let me do kill -l again. As I have already said that you can catch a signal, you can write your own handler for that, you can ignore a signal, you can block a signal, but there are two signals that cannot be caught. One is the signal number 9, the sig kill. This is a signal which is known as a silver bullet in UNIX. No process is capable of catching this signal or ignoring this signal. Whenever this signal is delivered to a process, it will be killed. The other one is sig stop, signal number 19. So signal number 19 and signal number 9, these are the two signals which are non-catchable. They cannot be caught by a process. So let's see that if we can do some. Let me run a process sleep. So this sleep process is running on this terminal. Let me open another terminal and let me say ps-a. So we have a sleep process. I want to send a signal to this sleep process. So one way is that if this process is running in the foreground in front of me, I just press Ctrl C and the SIGINT is given to this process. Let me run it again. I press Ctrl plus \. So SIGQUIT is given to this process. So let me run this process again. I press Ctrl plus Z. So this process is suspended or stopped. I can continue this process by doing the FG, which we have already done before. So now again this process is running in the foreground. If I'm sitting on another terminal, I want to send a signal to this process sleep. So I have a command kill and I pass the ID of this process 15793 and I press enter. You see this process is terminated. This sleep process is terminated. Let me do it again. Sleep 100. Let me come back over here and check out ps-a. This time again sleep is running with an ID of 15803. So I run this command 15803. If I press enter, a signal will be given to this sleep process. Which signal? Signal number 15. Signal number 15. If you do not mention a signal over here to the kill command, the default is it sends the sig term or signal number 15. You can mention another signal number, for example signal number 9, which is a sig kill. I press enter and you come back over here and you see the sleep process is killed by this signal. We have other commands as well to send signals. Let me show you another idea. Events. Do I have a PDF file over here? Yes, I have a PDF file, nasm.pdf, EVINCE. So events is a program that is used to read PDF files. I press enter. So the PDF file is open in front of you. I can view this file on this terminal. Let's suppose, let me say ps-a. So the events program is running. Let me pass a signal to this events program 15827. So if I press enter, sig kill will be passed to this events program. There is another command which is kill all. You can see the man page of kill all as well. Kill all is used to send a signal to a process by its name, like let's suppose events. I press enter and you see the events process is killed. Kill all is used to send a signal to a process by its name. If more than one process runs with that name, all of them will be killed. You can also use kill and send a signal to a process with this ID, and if you know, instead of the PID, you know the job ID of a process, you precede this ID with a percentage sign. in case if you want to kill a process by the job ID instead of PID, you precede the number with a percentage sign. Okay, fine. Let me briefly talk about the ignoring of the signals as well on the shell. There is a command that is known as trap. Let me see the man page of trap. Okay, it is a built-in command. Yes, it is a built-in. So to find out help on a built-in command, I use help trap. So please read this page. It contains a lot of information about trap. So let me briefly tell you what it means. I say trap and then I mention some command. For example, echo learning Linux is fun. And then I give a number, and then I press enter. What has happened is, whenever the shell program which is running right now in front of me will receive the signal number 2, it will execute this program now. Instead of terminating, this program will be executed. So I have written my own signal handler for signal number 2. Okay, let me do it to, let me press Ctrl plus C. You see? Okay, let me say that you can't kill me with CTRL plus C. Okay, Control plus C. Let me do not use this. Okay, fine. And now I press Control C. So it says new line token. Why this new line token has come over here? Okay, have I successfully written it? Yes, I have, but the line has gone a bit long. Okay, let me do it again. Trap echo you have pressed Control plus C. 2. Control C. You have pressed Control C. Fine. Let me do something like this as well. Control plus backslash. Enter. And if I press Control plus backslash, you get this character. Oh, the backslash is not visible over here. Anyway, so what I have told you that using this trap command, you can write a signal handler of this signal, which is this command. Let me ignore a signal. Trap 2. Control plus C. Nothing happens. Let me run a program sleep. Now I press Control plus C. Nothing happens. Control plus C. Nothing happens. But if I press Control plus backslash, the program terminates. Let me run trap 2 and 3. Now I have told the shell that you should ignore signal number 2 as well as signal number 3. I say sleep 100, and on this terminal, let's suppose I check out ps-a sleep. I say kill -2 15861. You see the sleep process is running over here. I've sent a signal to the sleep process and it has not been able to kill it. Let me pass 3. It has not been killed. Let me pass 15. So it has been terminated. So I've told you how you can write a simple handler of your own. I have told you how you can ignore a signal, and if you want to set the signals 2 and 3 to default, write down 2, 3. Now they have gone to default. let me check out. Sleep 100, I am pressing Ctrl plus C. I have pressed Ctrl plus C. The SIGINT has been given to the sleep process and it has terminated. Okay, so gentlemen, that was all about brief overview of signals. I strongly recommend that you must go through the chapter 7 of the main pages regarding signals. There are a lot of information on this page, and you must use the command kill and kill all. They are used to send signals to processes, and you must briefly know what all signals are available, particularly the standard signals like SIGINT, SIGHUP. Like SIGHUP is another important signal. Let me tell you what SIGHUP do. Whenever a user who has logged in that closes the terminal on and the operating system kernel sends a signal to all the processes, which is SIGHUP. So once again, let me tell you that SIGHUP is a signal sent to a process whenever you close the terminal or whenever the user who has launched those processes has logged out. The SIGHUP is sent to those processes, because no process is allowed to execute in a system whose creator or whose user is exiting the system, is logging out from the system. So these are the different signals which are used by processes, and we have seen their usage on the shell. We have seen their disposition. We have learned how to ignore them, how to write a basic handler of these signals of our own using the trap command, and hope you will practice them and it will be fun for you all. That is all, dear students. Hope this was informative, and hope to see you next time in the next session with some other subject or topic. Allah Hafiz.